We've seen in other videos in this series the practical side of inspection and testing, and we've touched on certain aspects of filling in the necessary documentation. So the question we must ask ourselves is, why is there a need for a video which examines more detailed aspects of filling in certificates and report forms?
The reason is, Dave, that it's actually amazing how many errors are made over and over again by contractors when they fill in the forms. And in this video, I think it would be great if we could look at the forms for domestic installations and discuss why we need them, when they should be used, who can fill them in, and the common mistakes that I've seen over and over again.
Although today we're looking at domestic versions of the certificates and report form, much of what we're going to talk about will be common to other versions as well. Now, we've already mentioned other videos, but there's also the Inspection, Testing and Certification book available from NIC EIC, which is an excellent reference book to have in your toolbox. It not only covers the documents that we're focusing on today, but also gives practical advice on inspection and testing. So because of this, there's no need in this video to examine every single box on the certificates. We'll instead examine the areas which traditionally cause problems for contractors when it actually comes to filling them in. First and foremost, certification is a fundamental principle in the regs, required by Regulation 134.2.1, which requires that after initial verification, that appropriate certification shall be issued. In Chapter 6.3, Certification and Reporting, Section 631 details the requirements for electrical installation certificates, electrical installation condition report, and minor electrical installation work certificates.
I'll summarise the requirements in simple terms. Upon completion of a new installation or alterations or additions to an existing installation, the appropriate certification must be issued. For new installations, rewires, or the provision of any new circuit, this will be an electrical installation certificate. For an alteration or addition to an existing circuit, it will be a minor electrical installation work certificate. For reporting on the condition of an existing installation, an electrical installation condition report must be used. This was a major change introduced with Amendment No. 1 of the 17th edition and replaced the periodic inspection report as the form to be used for periodic inspection and testing.
All of these documents can be produced in any durable medium, including written or electronic media, as long as the authenticity and integrity of originals and copies can be verified by a reliable process or method. Whenever issuing a certificate or a report form, they must be supplied together with a schedule of inspections and a schedule of test results for the scope of work undertaken. Model forms for certification and reporting are provided in Appendix 6 of BS 7671, and these are adapted in a user-friendly way by NIC EIC.
Dave, we've discussed some of the requirements of the regs, but actually there's a good common sense reason for issuing certificates and report forms, and that is that these bits of paper are often the only evidence a contractor has that he's been on site, that his work was left in a safe condition and complied with the wiring regs.
It is important to understand what issuing a certificate or report form actually means. A certificate is issued to confirm that the work undertaken within its scope has been designed, constructed, inspected, tested and verified in accordance with the current national standard for the safety of electrical installations, BS 7671, the wiring regulations.
On the other hand, an EICR is to report on the condition of an existing installation and to determine, so far as is reasonably practicable, whether it is in a satisfactory condition for continued service. And if you haven't already seen it, our EICR video is well worth a watch to help you get a grip on the subject.
Good plug, Tone. Okay, so we've established why we need them. Now let's look at when they should be used. So let's start by looking at the certificates. In what situations is it appropriate to issue an electrical installation certificate, Tony?
That's a good question, Dave, because surprisingly the answer isn't as straightforward as you might think. Its most common use is for new installation work, for example on a new build project where the electrician will be confirming the standard of the work and the safety of the whole electrical installation. However, it could also be used for a rewire, a consumer unit replacement or the installation of any new circuit.
So what Tony's saying is that although it has the word installation in the title, it doesn't always mean the whole installation. It actually depends on the details and extent of the work being carried out.
Yes, obviously for a new build or where a house has been completely rewired, it does confirm the standard of the whole job. But in cases such as installing a new circuit, it only applies to the work being done.
This is why both certificates have boxes requiring a detailed description of the installation work covered by the certificate, and also a box to write comments on the existing installation. Presumably, this is a place to record any defects the electrician may have discovered with the existing installation.
Yes, but only defects which do not affect the safety of the new work. Now, of course, you've got to use your nod here. Before starting any alteration or addition, it is essential to do a pre-work survey on the installation. The survey should cover items such as the incoming supply equipment, existing earthing and bonding arrangements, and consideration should also be made for any additional loading that the new work may place on the existing installation.
With a survey, it does give the opportunity to discuss any problems with the client prior to commencing the installation.
Now, if you don't see any defects, you must write the word none here.
If you're going to use a domestic electrical installation certificate, there are 4 conditions which must be met before it can be used. The first is that the electrical installation work relates to a single dwelling.
So that's a house or an individual flat. It's not a block of flats or the landlord's supply.
Secondly, that the design, the construction and the inspection and testing of the electrical installation work has been the responsibility of one person or organisation.
If it isn't the responsibility of one person or organisation, then our full electrical installation certificate will have to be used, which provides boxes for each relevant person to sign.
The third and fourth requirements are that the installation forms a part of a TT, TNS or TNCS system, and that the protective measure for fault protection is provided primarily by automatic disconnection of supply, ADS. And moving on to the minor domestic electrical installation work certificate, for what types of work should this be used?
The minor work certificate may only be used for an addition or an alteration to a single circuit that does not extend to the provision of a new circuit. So, for example, you might use it when extending an existing circuit, say a ring final circuit into an extension. But you have to use a minor work certificate for each and every circuit you work on. So if I also extended a lighting circuit into that very same extension, I would have to use 2 minor work certificates. And if the extension was a kitchen and I extended the existing cooker circuit into it, I'd have to use yet another one.
So what you're saying is that in the example you've just described, instead of 3 minor work certificates, it would make much more sense to use an electrical installation certificate and list the details of the circuits being worked on in the details of the installation box.
Exactly. But one final word on the certificates. Neither of these are used on their own to certify the commissioning of powered smoke and heat detectors. If you are installing these, then as well as the appropriate electrical certificate, you will have to issue an installation and commissioning of a fire alarm system in dwelling certificate to cover these devices. On the domestic electrical installation certificate, there's a box titled Schedule of Additional Records, where the details of additional certificates can be recorded.
Let's move on to the electrical installation condition report. When are these used?
Periodic inspection and testing is a growth industry. with reports being requested by landlords, local authorities, estate agents and increasingly homeowners when selling or purchasing a property. An electrical condition report is, as it says, a report on the condition of an existing installation. It is not a certificate and should never be used as one.
Due to the efforts of organisations such as the Electrical Safety Council, householders and people that are looking to buy houses are becoming more aware of the implications of poor electrical wiring, not only in terms of safety, but also the potential costs of a rewire and the redecoration if you buy a property without checking the quality of the wiring first.
Dave, I got a friend that fell into that trap. Before he bought a house, he did not check out the electrics. You should have known better.
Yes, if you want to see the story of my money pit, check out the video Think Electric, available from the Electrical Safety Council. So now, let's look at who should fill out and sign the forms. All three of the forms we're focusing on today are filled in by the person who undertook the work.
As you can see, we've got two sets of boxes for signatories. One for the qualified supervisor and one for the person who's responsible for the design, the construction and the inspection and testing of the installation.
In many cases, for example, if you're a sole trader, these boxes are going to be signed by the same person. However, in a larger company, the person responsible for the design, construction and inspection and testing will sign one set of boxes, and the results of the inspection and testing will be reviewed by the qualified supervisor who'll sign the other boxes.
The important thing to remember, Dave, that whoever fills them in must be a competent person. That doesn't mean they need to have letters after their name or even be registered with an organisation such as the NIC, although it does help. And it means that they will have sufficient technical knowledge, relevant practical skills and experience for the nature of the electrical work undertaken. And of course, they will be able to prevent danger for themselves and others at all times.
The final thing to talk about with regards to signing the forms is the responsibility placed upon those who do sign them. I've heard some contractors express concern about signing a certificate or report because they believe they may be confirming the whole installation is safe when their contract was only for a part of it. It's therefore important to remember when you sign these that the scope of the work undertaken is clearly indicated and described in the details of installation box on the certificates and the extent of limitations boxes on the condition report form.
In other words, you are only signing for what has been done and certainly not for work which has been carried out previously.
In this section of the video, we're going to examine some of the common parts of the forms which often either cause confusion or are filled in incorrectly.
The first thing to look at, Dave, are the boxes which require names and addresses. Each form has an area for the client's details, the address where the work is to be carried out, and also the company details of the contractor doing the work.
Sometimes it's possible that the client's address and the address where the work is being undertaken will be the same. So what's the acceptable way to fill in the form in that situation?
It's perfectly acceptable to write in the address location, same as client's details or something similar.
Okay, let's move on to supply characteristics.
Supply characteristics is relevant to all three forms, but more information is required to be filled in on the electrical installation certificate and the electrical installation condition report.
One of the things that can be a bit misleading here is that the boxes for supply nominal voltage are blank, which has often invited the recording of the actual measured voltage.
The reason why it's blank is that there are many variables for a circuit or installation. The supply could be AC or DC, single or multi-phase. It could even be ELV. So whatever you're working on, these values must be recorded.
As we can see, there are two boxes with nominal voltage written next to them, one identified with U and the other with U0. For public supplies in the UK, U is 400 volts and U0 is 230 volts for two-phase and three-phase supplies. For a single-phase installation, U should have not applicable and U0 should have 230 volts.
And remember, you must never record a measured voltage in these boxes.
Next we have nominal frequency, and again this is a blank box. But in the UK this would typically be 50 Hz. There are preferred frequencies listed in the regs, including 60 Hz and 400 Hz. For example, although rare, you might encounter 60 Hz on American Air Force bases located in the UK.
The final box included with supply parameters is external earth fault loop impedance, ZE. Now on the domestic electrical installation certificate, this is not a measured value, but a declared value determined by inquiry to the electricity distributor or taken from the design information.
The declared value of ZE for a TNCS supply is 0.35 ohms, and for a TNS supply is 0.8 ohms.
However, on electrical installation condition report, it requires just a measured value. Now, if we look back at the domestic electrical installation certificate, we can see that there is another box for a measured value of ZE as well.
The reason why the electrical installation certificate has both an inquired value and a measured value is to confirm that the intended means of earthing is indeed present, and also that the design criteria is accurate. For example, if your measured value of ZE was considerably higher than that of the value found by inquiry, it could have a knock-on effect on earth fault loop impedance value ZS for the final circuit, which would be higher than those calculated by the designer, possibly meaning that the specified circuit protection will not operate in the time required by the regulations.
The next thing to consider is prospective fault current. The forms do allow us to either determine this by inquiry or measurement. However, I would normally expect the boxes under supply characteristics to be filled in with the data from the design information. This, on most occasions, will be values determined by inquiry. Typical values are 16 kA for single-phase supplies and 25 kA for three-phase supplies.
On the EICR and domestic EIC forms, there's an additional box under test results for the actual measured value of prospective fault current. Because measured values are usually considerably lower than those obtained by inquiry and displayed in amps on some test instruments, it may on occasion be necessary to convert the readings of PFC from amps to kiloamps. This can be done by dividing by 1000. So for example, 1456 amps becomes 1.46 kA.
Don't forget as well that the prospective fault current is the highest value obtained from either the prospective short circuit current test or the prospective earth fault current test, and this is for each supply if there's more than one.
It's important to mention that some instruments will not be suitable to measure prospective fault currents on three-phase supplies, so check your instrument can before you do.
If your instrument doesn't, it doesn't matter, because it's perfectly acceptable to measure prospective short circuit current between each phase and neutral and multiply your highest reading by 2 to give an approximate value of prospective short circuit current for the three phases.
The next box, which some may find confusing, is number and type of live conductors. Now here we can see a number of boxes labelled as one phase 2 wire, one phase 3 wire, etc. So can you give us a quick overview, Tone?
Well, in a house, the most common box to tick is the one phase 2 wire. So we have two live conductors, line and neutral. One phase 3 wire relates to a single phase split phase supply, 230 to 460 volts. This is not common, but you could encounter it, say on farms, where a higher voltage may be necessary to operate some machinery. Three-phase 3 wire is often used in larger installations to supply motors and has 3 line conductors, one for each phase of the supply. And finally, we have three-phase 4-wire, which has 3 lines and a neutral. This will be for commercial, industrial and the larger domestic installations.
When you've filled in the appropriate boxes with a tick, it is good practice to put the letters NA for not applicable in the remaining boxes. The only part of the forms which actually lists putting not applicable as a requirement is the schedule of items inspected. Nevertheless, it is a good idea to do this throughout the rest of the document. Let's look now at the characteristics of primary supply overcurrent protective device. The first box requires the BS-EN number for the device. Typically, in a domestic installation, this will be either a BS1361 cartridge fuse or a BS88-3 fuse System C, which was introduced with Amendment number 1. For larger installations, you might find a moulded case circuit breaker, or in very old installations, a BS3036 semi-enclosed rewirable fuse. For new installations, it should not be a problem determining the characteristic of the device, but for an EICR, it can often be difficult to ascertain, and in some situations will have to be an agreed limitation of the report.
The next box says type. Now I've seen this filled in as new one or grey one, but what it's actually referring to is the type of the characteristic of the device. There is data available to help you determine the type of device in the on-site guide.
For example, a BS1361 fuse used as a primary supply of a current protective device will be type 2. The next 2 boxes are rated current and short circuit capacity. The rated current is fairly straightforward, as it's the rating of the fuse or circuit breaker.
Short circuit capacity, on the other hand, is the maximum fault current the device can interrupt safely. Looking back at the data, we can see that a BS1361 Type 2 fuse has a rated short circuit capacity of 33 Ka. And it's this value which must be higher than the prospective fault current we spoke about earlier.
There's a good point of warning here. On a periodic, if you did encounter a 3036 rewirable fuse as the primary supply overcurrent device, this could have a rated short circuit capacity as low as 1000 amps, depending on its designation.
The next group of boxes deals with the means of earthing. Now, if you have an earth provided by the electricity distributor and you tick the distributor's facility box, there is no need to fill in the remaining details about the installation earth electrode, other than to write none or not applicable.
This should also reference the system type box. So, for example, if you've ticked TT, you should not have a tick in the distributor's facility box. However, you should insert a tick in the installation earth electrode box. If you're on a TT system, you'll have to fill in the remaining details about the installation earth electrode. The acceptable types of earth electrode are listed in Regulation 542.2.3. It will also be necessary to measure and record the electrode resistance RA, and you must also write down how this was measured, because there are several test methods that can be used. For example, where there's a supply, a loop impedance tester may be used, or where there's no supply, by using an instrument and proprietary earth electrodes to undertake the fall of potential method.
However, recent developments in test equipment have also introduced a new non-invasive test where there is no need to disconnect the earthing conductor or connect to live terminals. You can instead use clamps. So an overall safer approach to obtaining the earth electrode resistance.
Remember that the resistance value you get should be as low as practicable, and that values above 200 ohms may become unstable, particularly in dry or frozen conditions.
Finally, for earth electrodes, we have location. Now I've seen this filled in with outside or in the ground, which isn't very helpful to the person who comes along for the next EICR. So it's better to write down a fixed point of reference. For example, 1 metre from the kitchen window, or as we can see in this picture, 1.5 metres from the side of the garage.
The next box to examine on the certificates deals with protective measures for electric shock. Now this in most cases is automatic disconnection of supply, ADS, but can be followed by one or more of the protective measures detailed in Chapter 4.1 of the regs. So for example, double or reinforced insulation could be recorded for a circuit supplying a non-metallic hand dryer, which is a common example of equipment adopting this protective measure. Next, let's look at boxes referring to protective conductors.
First, we have the earthing conductor. The conductor material will generally be copper, but it could be aluminium or steel, and the cross-section area needs to comply with the requirements of Regulation Group 542.3 and Section 543. Here you will find detailed information on how you can either select a suitable cross-section area or calculate it.
Within the section concerned with protective conductors, there is a box to confirm that both the connection and continuity of the conductor has been verified. This could either be a visual means of checking continuity or confirmed by testing.
Just to let you know that when we say visual check, we mean that you can see the entire length of the conductor. So even though it might only be for a couple of meters, if it passes through a wall at any time, you will have to confirm continuity by measurement. Next, we have the main protective bonding conductors. Conductor material will most likely be copper, and the cross-section area must be what you actually see on site, not the design information where you have it. There are several tick boxes for the various extraneous conductive parts. For example, water, gas or oil. You would expect to see either a tick or an NA in each box, but for an EICR, you might also have a limitation or an outcome code referring to the urgency of the remedial action required, which we will discuss later. Any limb you write must be fully detailed in the limitations box on the front of the EICR form.
Let's now look at the section for main switch or circuit breaker, which you won't find on the minor works certificate. Here we can see box type, voltage rating, number of poles, rated current IN, RCD operating current and its operating time, measured at fault current.
A lot of this information can actually be picked up from the device. On this main switch here, we can see that the current rating is 100 amp, it's rated at 230 volts, it's a BSCN 60947-3 and it's a 2-pole device.
The boxes requiring RCD operating current and operating time would only require values where the main switch incorporates an RCD, otherwise not applicable should be written here.
Yes, and remember it's the details of the main switch, not the RCD sitting beside it.
Let's now consider the schedule of items inspected, found only on the electrical installation certificate and not the EICR. Now we cover this in some detail in another video and also in books. So in this video we'll only consider some of the additional considerations which may have to be made. The first of these being cross-referencing the schedule to data filled in elsewhere on the form you're filling in.
A good example of this are some of the boxes under the subheading Automatic Disconnection of Supply. In particular, presence of main protective bonding conductors. If there is an NA, for example, because a building has no water or gas, then you would not expect to see a tick in the relevant boxes for bonding of extraneous conductive parts. We see this kind of thing more often on electrical installation condition reports.
The same issues are true for any box on the schedule which is confirming the presence, and in some cases operating current, of an RCD. If there's anywhere else in the form which records details about RCDs, this should be cross-referenced to the schedule and should agree with it. A common misinterpretation can occur when electricians confuse requirements for RCDs to provide additional protection against electric shock and those, say, which may be installed to provide fire protection. For example, a 300 mA RCD which may be provided for fire protection would not result a tick in the box presence of residual current devices under the subheading of additional protection. This instead would fall for consideration under the box choice and setting of protective devices.
Another thing to point out is that no box on the schedule should be left blank. For the electrical installation certificate, there should be a tick or a not applicable in every box.
It's important to remember that the inspection schedule only relates to the work that you've carried out. For example, if a new cooker circuit is installed, then more than likely you wouldn't be checking for supplementary bonding, segregation of safety circuits, CELV, etc. And therefore these boxes will have NA. The circuit details and test results take up a full page on both the EIC and EICR, whereas the minor work certificate only deals with information for a single circuit and so has an abridged version. So the first issue I'd like to tackle, Tony, is how this should be filled in to best represent the installation you're working on. Now, for example, it's common to have a split load consumer unit with 2 batches of RCD protected circuits. So what's the best way to show this on paper?
Well, Dave, there's no hard and fast rule on this, but here's an example of what I would do. As you can see, each RCD takes up 2 rows, which gives me plenty of room just to write down the circuit it protects. These circuits are then written underneath with the circuit number. I've also used a ruler to bold up the line before the second RCD and its associated circuits. Depending on whether the form has pre-printed circuit numbers, it may be necessary to either overwrite these or write the actual numbers under the circuit designation column.
Most of the columns requiring information about each circuit are fairly self-explanatory, but we will quickly run through each. Next, we have type of wiring, and in brackets, it's got C code.
For ease of information, the codes are listed on the side of the page. For example, code A means the type of wiring is thermoplastic insulated or sheath cables. There is also an option of O, meaning other, and a box for you to describe the type of wiring used.
The column for reference method refers to Appendix 4 of the regs and to methods of installation to which current carrying capacity has been determined by test or calculation. Table 4A2 of the regs gives examples and a description of installation methods and reference method to be used to determine the current carrying capacity of the cable.
For example, if I look at table 4D5, which is the current carrying capacity for twin and earth cables, you'll see that there's 6 reference methods. Reference methods 100 to 103 are to do with thermal insulation, depending on the thickness of the thermal insulation. And reference method C is if the cable is fixed direct. Now it's these reference methods that will go in the box on the circuit details.
Next, we have number of points served. Now this is referring to the termination of the fixed wiring intended for the connection of current using equipment. For a lighting circuit, this is only the luminaires served, not switches or number of individual lamps used.
And for socket outlets, if you have 10 double sockets, you have 20 outlets, but it's still only 10 points.
Next, we have the cross-sectional area of live and CPC conductors. If you're using standard twin and CPC cables, you shouldn't have many issues here, as there are tables published for the complete range of conductors from 1 mm squared up to 16 mm squared.
The next column is titled Maximum Disconnection Time Permitted by BS 7671. This is the value determined by the designer from the relevant table in Chapter 4.1 of the regs, and is information that we need to cross-reference later with the ZS test results. You will see from Table 4.1.1 that for circuits not exceeding 32 amps on a TN system, the maximum disconnection time is 0.4 of a second. For a TT system, the maximum disconnection time is 0.2 of a second. For circuits exceeding 32 amps or distribution circuits, the disconnection time can be extended to 5 seconds and 1 second respectively.
The next 4 columns deal with the details of the overcurrent protective device for each circuit. For circuit breakers, this information can be taken from the device, just as we did for the main switch.
However, where not available, you may have to consult the manufacturer or refer to other published guidance, such as the on-site guide. The capacity is referring to the braking capacity, so the current which the device can interrupt safely. And for a BSEN circuit breaker is displayed in a rectangular box. As the heading of the column is KA, it may be necessary to convert from amps to kiloamps. The following column is for the operating current of any RCD protecting the circuit. Don't forget this includes RCBOs. For our circuit detail sheet we saw earlier, it will only be necessary to fill in the RCD details in the rows set aside for the two RCDs. And then you can put a ditto in the rows underneath for each circuit.
Next, we have maximum ZS permitted by 7671, and this information is taken from the relevant table in Chapter 4.1. For example, our cooker circuit is protected by a 40 amp circuit breaker, and Table 4.1.3 tells us that maximum ZS is 1.15 ohms. Well, that's the circuit details covered. We now have the test results section. The first three columns are for little r readings for ring final circuits only, and not applicable can be recorded for all other circuits. Next we have two columns for big R readings for all circuits, but only one column need be completed for each circuit. For initial verification, it is good practice to do the R1 plus R2 option. The R2 test is usually undertaken on periodic inspections as a convenient method of determining that a CPC has been provided at every accessory and outlet.
One quick word about the big R1 plus R2 box. I've seen this filled in for ring circuits with the values of little r1 plus r2 added together. This is wrong. The correct values are achieved during step 4 of the ring final circuit continuity test, when a line conductor from one leg of the ring is cross-connected to the CPC on the other leg and vice versa, and resistance readings taken between line and CPC at each socket outlet. The highest value going in the big R1 plus R2 box.
The next four columns are for the results of insulation resistance tests. The first column, line-to-line resistance, is for a three-phase circuit where tests are undertaken between each phase of the supply. The lowest value of resistance measured should be written in the box, or not applicable if the installation is single-phase. Then we have line and neutral. Again, for three-phase, you would have to test between each line conductor and neutral and record the lowest value. And repeat again for the next column, line and earth. Finally, there is neutral and earth. Tony, although there are boxes for each and every circuit, the wiring regs do allow for insulation resistance to be taken on the board as a whole. So if you've done it that way, is there a preferred way to fill in the form?
Well, you can do it in a number of ways. There's nothing wrong with writing a value in every box. Although, if you have, I think you should write on the form how you did the test. For example, ball tested as a whole. Alternatively, you could fill out the top boxes and then add a bracket like this with additional commentary.
What about if you've done the alternative test with line and neutral cross-connected, so you reduce the chance of damaging certain equipment?
For that, I would cross out existing words and write in the top row L and N to E, meaning line and neutral connected together, tested to the earthing arrangements. I will then draw a bracket and write the resistance readings before filling in the rest of the boxes with dittos.
Next, we have a column for polarity. Now this box is only a tick box, there's no value required. As we've seen in our other videos, there are a number of ways of confirming polarity, and the tick confirms that this has been undertaken for every connection of the circuit. So there is a possibility that on a condition report you might find limb written here. For example, if it wasn't possible to gain access to a socket outlet concealed by furniture. Remember, any limbs recorded should also be detailed in either the agreed or operational limitations box on the front of the condition report, which we'll look at later.
Next, we have maximum measured earth fault loop impedance. And this is another box which can cause problems, especially when compared to the box maximum ZS permitted by BS 7671. Usually, what happens is the electrician takes a reading, sees that it's lower than the maximum allowed ZS from the regs and thinks everything is fine. Unfortunately, the maximum ZS needs to be adjusted by the 80% rule of thumb method before comparison. This allows for the difference between conductor temperature during normal operation and the colder conductor temperature during testing.
For example, if the maximum ZS for a circuit in the regs was 2.3 ohms and the measured ZS was 1.9 ohms, on the face of it everything seems fine. But reduce the maximum allowed ZS to 80% of its value and you get 1.84 ohms, which tells us we have a circuit which may not achieve the required disconnection time of 0.4 of a second in the event of a fault.
Don't forget that all the NIC certificate and form pads have the 80% values on the inside front cover. These values are used for comparison when testing, but not to be recorded on the certificate or report forms. Next, we have two columns for RCD operating times. The first is the operating time at the rated residual operating current of the RCD, which is required for all RCDs and RCBOs. The second column is for the disconnection time when tested at 5 times the rated residual operating current. This is only a requirement for RCDs installed to provide additional protection against electric shock. So RCDs with a rated operating current not exceeding 30 milliamps. There is a third column here for checking the operation of the RCD by pressing the manual test button. If the RCD operates, a tick shall be inserted here. Before we leave this section, Dave, there's just a couple of other boxes that can be incorrectly filled in on this sheet. The first is designation of consumer unit. This should be how it's described by the manufacturer. For example, 12-way split load. It's not for the manufacturer's name. I even once, many years ago, saw someone write the name Gary in here. It wasn't right, but it had me laughing for days.
I suppose you're going to tell me next you've seen on the wall written in location of consumer unit.
Don't have to answer that, do I?
Again, for this box, the location should be a recognisable description. For example, kitchen, garage or understairs. And finally, at the bottom of this sheet are boxes for the serial numbers of any test instruments used. This is vital as it allows for the instrument calibration history to be checked with the manufacturer if required. If you're using a multifunction test instrument, it's considered good practice to put NA in the other boxes.
Actually, Dave, we should just quickly mention the first line on the schedules page, which is only to be completed where the consumer unit is remote from the origin of the installation. So we will put the details of the circuit supplying the consumer unit in here.
We're now going to focus on some of the particular issues with the minor works certificate. As this is only used for an addition or alteration to an existing circuit, it's just a single sheet of paper. So, for example, it doesn't have separate circuit schedule and test results. However, much of the information we've examined so far in this video will be required in Part 2 and Part 3 of the certificate.
There are two boxes in particular which require important consideration. The first is details of departures, if any, from BS 7671. Sometimes it is thought that this is always referring to departures in the existing electrical installation. This may be the case, for example, where a circuit protection device is manufactured to BS 3871, which is a standard no longer recognised by the current regs. But its use is also for situations such as where possible non-British or European standard equipment is being installed as part of the work.
Yes, this is one of those cases where allowance is made by the regs as long as it can be proved that the equipment installed is no less safe than similar equipment which does meet the required standard.
It's more common for comments on the existing electrical installation to be placed in the big box under details on the modified circuit.
And how far would you expect the electrician to go with regards considering the existing installation?
It's about making a judgment. If you see enough problems to give you doubts about proceeding with the work, it may be appropriate to recommend to the client that an electrical installation condition report be carried out. If they don't want to do it, and you've seen problems which you consider dangerous, You may like to issue them with a domestic electrical danger notification. The client may not want to sign it or accept it, but as far as the electrician is concerned, he has taken appropriate action.
Before leaving the minor work certificate, is there anything in the inspection and testing part that needs clarification?
Well, as you can see, it's an abridged version of the inspection and test schedules we saw earlier, and everything on it we have examined. I will point out though that although the minor work certificate is for an addition to a circuit, we are still required to verify by visual inspection that there's an earthing conductor connected to the consumer unit from the means of earthing, and also that where protective bonding is required for extraneous conductive parts, it exists.
Finally, under this section, we have agreed limitations, if any, on the inspection and testing. Now, we'll examine this more when we look at the electrical installation condition report form. But the important word here is agreed. Any limitation must be agreed with the client, ideally before the work has even started.
Before we leave the minor work certificate, as previously stated, remember, it's one minor work certificate for each circuit worked on.
With the introduction of Amendment Number 1 of the 17th edition, a major change was that the form used for periodic inspection and testing altered considerably, not only changing the name to Electrical Installation Condition Report, but also the way observations are coded, and it includes a comprehensive list of items that require inspection.
The number of changes, especially the detail on the inspection schedules, are considerable. And I recommend watching our video on electrical installation condition reports, which goes through the schedule in detail.
For this video, we'll focus on some of the key areas. And first, let's look at the purpose of the report.
Now, I've seen all sorts of stuff written in here. A particular favourite was to check the condition of the electrical installation. Now, if they'd added the words "because the required next inspection date on the electrical installation certificate was due," this would have been fine.
You could also have checking condition of electrical installation after a fire or flood, or due to possible house purchase, mortgage or remortgage, as long as the reason is clearly understood. The next boxes we're going to look at are incredibly important, and these are extent of the electrical installation covered by the report, agreed limitations and operational limitations.
The first box is extent of the electrical installation covered by this report. In some cases, this might be second floor only, or downstairs lighting only, or it might be whole installation with the exception of the smoke alarm circuits.
The agreed limitations box ties in with this. It is vital to agree with the client before you start what you can and cannot do. This is all about providing evidence in the future if required.
It's important to state that this box requires that you must also state whom it was agreed with and the reasons.
So what kind of things might we find in the agreed limitations box?
Well, a common one is likely to be that no insulation resistance test was made between line and neutral. The reason would be because all lamps and current using equipment would have to be removed, and in most cases this is totally impracticable.
The next box is operational limitations. So what's the differences between that and an agreed limitation?
That's a very good question, Dave. Agreed limitations have been agreed with the client before you start. However, operational limitations are issues that have arisen whilst carrying out the report, which have prevented either inspection or testing of a particular item. Again, the reason must also be recorded.
An example might be that access may be restricted to lighting, perhaps because of height or because a loft is inaccessible. Another change with the EICR is the codes used to classify observations.
There are 3 observation codes used to determine the degree of urgency for immediate action. These are C1, C2 and C3.
C1 means danger present and immediate remedial action is required.
C2 means potentially dangerous and urgent remedial action is required.
Code C3 means improvement recommended.
When it comes to making the overall assessment of the condition of the installation, any C1 or C2 conditions that have been identified must result in an unsatisfactory outcome.
Sometimes it will be necessary to indicate that further investigation will be required to decide whether an observation does pose an immediate or potential danger. If this is the case, the overall assessment of the condition of the installation must also be reported as unsatisfactory, as detailed in the Best Practice Guide on Electrical Installation Condition Reports produced by the Electrical Safety Council.
The condition of the electrical installation and the number of codes and their severity will have an effect on the decided date of the next inspection.
The date of the next inspection is at the discretion of the inspector. For example, in our EICR video, the property has lower insulation resistance values than would be expected for its age. Therefore, Tony set the next inspection to 6 years.
The final box for us to discuss on the EICR is the summary of the condition of the installation. Now, I've seen poor or needs a rewire here, but these are not accurate statements. In real terms, you should provide a clear summary of the condition of the installation, having considered, for example, the adequacy of the earthing and bonding, the suitability of the switchgear and control gear, the types of wiring system and its condition, the serviceability of equipment, including accessories, the presence of adequate identification and notices, the extent of any wear and tear, damage or other deterioration, changes in the use of the building which have led to or might lead to deficiencies in the installation.
Because there's only a finite space for this information, it is advisable to send a covering letter to the client with the completed EICR. This is a chance to expand and explain upon the summary in non-technical terms, and also provide a recommended list of remedial actions. We're going to finish today by looking at information particular to the electrical installation certificate.
One box we didn't discuss is maximum demand, which is under particulars of the installation at the origin. Normally, this figure would be the maximum demand taking into account diversity calculated by the installation designer. However, for work which is adding additional circuits and loading, it may be necessary to determine the existing maximum demand before commencing with the work, so that it can be ascertained that the wiring and the equipment installed, especially at the origin, is suitable for the additional load.
One acceptable way to determine a realistic maximum demand on an existing installation is to use a clamp meter where possible at the line meter tail, and then switch on as much current using equipment as possible. So what next, Tone?
The final box to discuss is the number of smoke alarms. We discussed these earlier, and although you can write in the quantity, you must remember that the additional certificate entitled Certificate of Design, Installation and Commissioning of a Fire Detection and Alarm System of grades B, C, D, E or F in a dwelling must be issued as well.
And anything else?
I'd finally like to remind everyone that if the electrical installation certificate is for an initial verification on a whole electrical installation, then there must be no crosses or limitations on the certificate. If any defect was found, for example, damage caused during construction, then this must be rectified before the certificate can be issued.
In this video, we've examined some of the key features and applications of the Minor Domestic Electrical Installation Work Certificate, the Electrical Installation Condition Report Form, and the Domestic Electrical Installation Certificate.
For further guidance, check out other publications available from the NICEIC and Electrical Safety Council, and also the superb videos featuring Dave and me.
See you soon.